Welcome to this one more particular lecture on the scattering theory, and in this particular lecture we will look at the bond series, right? So what the bond series are. So it is just the basic calculation. So I have written down the calculations already so that I'll not take you a lot of time. So bond series, or you can say the series of outgoing waves, wave function of scattered particle using Lippmann-Swinger equation, right? So these are just the series corresponding to the scattering particles, and we will calculate these series, the bond series, by using the Lippmann-Swinger equation. In the last lecture, we have calculated or derived the Lippmann-Swinger equation from the differential equation, the Schrodinger equation, by using the Green's function technique, right? So this was the Lippmann-Swinger equation, right? What we can do now is that we can take approximate solutions of this particular equation, and as you have studied in the in the approximation technique methods, that we can take some zero order, first order, second order approximations, but here the approximation is a little different. But the zero order approximation or zero order solution is just the solution where the scattering potential is zero, right? So the zero order solution of Lippmann-Swinger equation means that there is no scattering, right? So the solution will be just the incident particles. So the solutions are just incident particles, and we know that incident particles are just the plane wave functions. So it is just e to the power iota k naught dot r. This is just the zero order solution of the Lippmann-Swinger equation. For the first order solution, what you have to do, you just have to replace this particular function by the zero order approximate solution. So you just have to replace on this particular place the zero order approximate solution, and you will get the first order solution of Lippmann-Swinger equation. To get the second order Lippmann-Swinger equation solution, you just have to replace for this particular function as the first order solution. So in the second order solution, what you have to do, you just have to replace this particular function by the first order solution. And when you will put this particular for this particular first order solution from this particular equation, you will get this particular series, right? And in the same way, you can calculate the third order, right? Psi 3r and psi 4r and so on. And this will be like a series because there are just single term. These are just two terms in the first order solution. In the second order solution, there are these three terms. This is the first term, and this is the second term, and this is the third term, and so on, right? If you will calculate the third order solution, you will get more and more terms, and for nth order solution, you will get a series where there will be so many terms. So it is just kind of series, and these solutions at the first order, second order, and nth order solutions are called the bond series because it is just will be a mathematical series, right? And this is just what I just want to say in this particular lecture. And these are the wave functions, so you can say series for the wave function, the outgoing wave function of the scattered particle, and this we calculated by using the Lippmann-Swinger equation. So this is what we can just do, and these are called the bond series. So this is it in this particular lecture. Thank you.